Alright, so gone ahead and taken out the old power supply capacitor section. And it's this board right here. It was sort of mounted right here, and I think I'm going to mount the new one there as well. Um, so essentially what it is just a piece of this sort of perf board, breadboard, if you will, that I've added some turrets to. Made it into a turret board, and it'll mount to the chassis with these metal standoffs that are these are threaded 4-40 standoffs that I use, that are they're sort of swage mounted onto the board, just like the standoffs are swage mounted also. And so what I'm going to do is I've gone ahead and already cut out a new piece of perf board, and it's a bit longer. Set the holes up to match the existing holes that I drilled in the chassis. This chassis is steel, and it's pretty difficult to drill into, being mounted the way it is. So I'm going to try, and I want to try to minimize any drilling into the chassis. So I'm going to reuse the holes that I already drilled. I'm going to put new mounts on this one, but I'm going ahead and made this one bigger. It'll fit. It's going to fit nicely right in here, where the other one was, between this switch stack and the power transformer here. And but it's longer, so it'll give me more room to mount the capacitors and the resistors. And I think I'll rearrange the configuration here, and maybe move these two capacitors in, and bring these resistors out to the edges, and bring this one out from between the capacitors like it is here. Of course, these two big ones won't be here on the new board. So what I've got to replace it is this large single section can here. So this is a Nishikon aluminum electrolytic, 330 microfarads, 450 volts. The original spec on the schematic, which is this capacitor right here, calls for a 300 microfarad section. Of course, if you look at the parts list in the manual, it's rated for 450 volts. So this cap will work just fine, being a little bit higher than the original spec, but that's no problem. And this will replace these two here. And what I'm going to do with Matt is use this clamp, which I'm going to mount to the underside of the chassis. And luckily, as you can see, the holes that were there for the original can will line up, if I can get it sort of stuck in there like that. But yeah, so the holes will line up nice. So no drilling. I'll do more drilling, and of course this will be mounted to the underside, so it'll actually be mounted like that. And then once that's mounted, so this can is 30 millimeter cap, and this is a 30 millimeter clamp. So this will just go in sort of like that, and then I'll have it stick up through the chassis like that, and then I'll run it, wire it with some leads to the strip board. So that'll clear off these two caps, and then that'll leave me with the rest of these plus the resistors. And we'll rearrange the resistors to get them out of in between the caps, so that the heat, because like I said, these resistors put off quite a bit of heat. As you can see, they're high power. This is a 10 watt, and these are all 5 watt resistors, and they do get very, very warm. That'll get the heat off the caps, and hopefully that'll extend their life a little bit. But anyway, so that's the next thing that's going to happen. I'll get this board laid out the way I want it, and then we'll go from there. Alright, so I've got my strip board now. It's already got the standoffs mounted to it, and the standoff that I use is this Mauser, well, let's say it's actually a keystone standoff. It's like I said, it's a 440 threaded standoff, and just mounts in a 3/16" hole, and it's a swage mounted, so the bottom flares out, and there's a tool that you use to flare out the bottom. Let me get it out of the bag here. But, essentially, you just put it in and sort of pound it out, and do it with a hammer on an anvil or something hard, not wood, because it'll just pound into the wood. But then you can flare it out, and it does pretty good. It gets a nice. I always check to make sure it's all flared out evenly around all the sides, and you don't want it sitting in there sideways. But anyway, and then the standoffs will mount are these standoffs here. These are a keystone turret standoff. I think it's a part number 1502-2. They mount in a 3/32" hole, and they look like that. And so I've got the holes already drilled for the components how I think they need to lay out. And next thing we'll do is we'll mount all the standoffs on the board, and I'll show you how I go about flaring those out. Because again, these are also swage mount, so you got to flare the bottom out to keep them mounted on the board. All right, so this is the tool I use. This is it's a homemade tool. Got the idea from watching another video a few years ago where they did something similar. Basically what it is just go to like a hardware store or like Lowe's or wherever and get you a nice stainless steel bolt, and cut the head off. And then I've filed this down to a point using the I put it in the drill press and just ran the drill press and ran it down with a file. But you can do it with a grinder probably the same way. And then there's I threaded a Teflon nut onto it. Of course, do that before you cut the head off, but just to use as a stop. It's not really necessary, but it's a stop in the chuck. And so that's the press, and then the die that I use is another bolt. It's a bolt kind of like this one. This is actually a die for a smaller turret that I have. I won't be using that one this time. But anyway, so just a bolt, and drill a hole down in the center of the bolt that's just a little, that just fits the turret you want to use. So this is sized for the particular turret that I'm going to use. And what happens is the turret itself will sit down, but the base of the turret is too wide, so it'll rest against the top of the bolt here, so that when you press down, when pressed down, so this will go in the drill press, and then we'll press it down. It's just like basically an arbor press to flare out the bottom of the turret. We'll do that next. Of course, the trick to all this working is, of course, you got to line the bolts. So I've gone ahead and mounted this piece into the drill press, and I mounted the anvil down there in the drill press. And of course, they have to line up. That's the trick. You got to get them to line up. It takes a little bit of fiddling with, but line them up and then tighten it down into the base of the drill press. And now we'll put some turrets in. All right, so now we're ready to put the turret in. So we'll put the turret down into the base, and so as you can see, it's sitting right there. The top part of the turret will go down, like I said, and the base, which is a little bit bigger, will sit there on top. And make sure that we get this board facing the right way. We want the turret on the top side. I've messed that up before, but we'll put the board in, and now if I can do this one-handed, the turret, get it lined up here. There it goes. Alright, and we'll push it down. Just a little bit of force to swage it out. And there we go. So now it's pressed on there, as you can see, and it's not going to come off. So that's just a quick and easy way to do. You can make a press for your turrets, and like I said, you know, this is sized for this one type of turret. So if you use different types of turrets, you'll have to make different presses. But anyway, that's how I get the turrets on anyway. Alright, back at the bench, and the turret board is all complete. The turret's mounted and swaged in there. They're not going to come out. So the next thing we're going to do is we'll populate this board with our components, and once we get that done, then we'll get it wired into the oscilloscope.